Today we're going to look at functions a little bit differently. We're going to look at something called a composite function. This is going to build on what you know so far about functions, just take it a step further. So what is a composite function? The word composite means, as you can see here, something that's made up of different elements or parts. So those of you applying to college, you'll be looking at seniors will be looking at something called a composite SAT score. Maybe you've seen this before, composite SAT score. And that's basically just your two different sections, so the math section and the reading section combined into one score. So you can think of composite as like combining different things into one thing. Another example would be from if you own your own company one day or you ever work in finance, companies use these things called composite indexes. And a composite index is basically a measure of how well your company is doing, but it's combined all these different elements. So one element could be profit, one element could be employee satisfaction. So it's combining different elements of how well your company is doing into one score, composite index. There's also lots of examples from sports. If you want to look up like a composite baseball score, that's a thing as well. So in math, what does it mean to have a function that's made up of different elements or parts? Well, the technical definition that comes right from your textbook is the output of one function is the input for another. So, as with most cases, this definition is not super helpful until we actually do the math and then maybe come back and revisit it and think, what does it mean for the output of one function to another function? So, the way that I think of it is, let's make a little diagram here. So most of the time, composite functions will be like f of, parenthesis, g of x. So the important thing to notice here is that there's two functions. There's f on the outside and then there's g on the inside. Let's use a little bit of visualization to see this clearly. So this purple function is one piece. It's the outside function. And then this g is actually a totally different function. And this is inside of f. So the way that I think of it is I always think of the outside function as a mom. So this outside function is a mom, a pregnant mom, and inside the mom's stomach is a baby. So this is actually, it seems very silly, but it actually is going to be very helpful as we go on with class today. So we have the mom, F is our mom, and then G is our mom, F is pregnant with our baby, G. Okay, and this baby, sometimes we'll also call it the inside function. It is inside the pregnant belly of the mother. Okay. So, how are we going to evaluate these crazy looking composite functions? The first thing we're asked to do is evaluate g of f of 2. G of f of 2. So what I'm going to do for this example is I'm actually going to divide into two columns. On the left side, I'm just going to show you the math. And then on the right side, I'm going to show you some writing or some justification for what I'm doing. So here, a good thing to do first would be to identify the mom and the baby function. So I'm just going to rewrite my expression I was given, g of f of 2. And the writing here is going to be mom is g, baby is F. And let's keep going with the color coding. I have my baby function inside the mom, G. Okay, so the key here to evaluating this is going to be to move from the inside out. In other words, we're going to start with the baby, evaluate the baby first, and then we're going to evaluate the mom. So you always evaluate the baby first. So evaluate baby first. And over here, if I evaluate the baby, so I'm just going to ignore the mom for a second, the baby is f of 2, and thank goodness I already know how to do this. To evaluate f of 2, I have my function, my table up here. I'm going to look at f, and I'm going to look where x, or the input, so I'm going to look for where my input is equal to 2, and when x is 2, f of x, or the output, is 4. So a little reminder that 2 is my input, or my x value from my table, and 4 is my output, or my f of x value from my table. All right, so now I can rewrite this f of 2. I just realized it's equivalent to 4. So I'm going to rewrite this as g of 4. So, lest you forget, this is still my baby. 4 is still my baby. G is still my mom. I just evaluated my baby to make it look a little bit more simple. So I went from this complicated thing to just G of 4, which what I'm going to do is go into my table, see where x is equal to 4, because now my input is 4, and when the input is 4, the output is, for G, 74. And that would be my final answer. So evaluate baby first, and then the next thing I did, I evaluate mom second. And when I evaluated mom, I just said, okay, G of 4 is equal to 74. And that came right from my table, where I saw G of 4. When the input is 4, the output for G is 74. Okay, so if you're feeling confident, I encourage you to skip ahead in the video or pause and go to example 2, check your work. If you want to see one more example done out by me, then keep watching. Okay, ooh, interesting. Example 2 looks like similar thing. We have G of f of 2, and now we have f of G of 2. So our f and our G have switched positions. The baby became the mom, and the mom became the baby. The inside and the outside function switched places. Let's do the same structure. Math and writing. Okay, so let's start just by writing that I need to evaluate f of G of 2. Who's your mom? Who's your baby? Very important. My mom is F. My baby is G. They switch places, which is going to change the whole answer. Okay, so let's start by key, evaluate baby first. And we'll talk about why that is a little bit later. We're going to evaluate G of 2, just looking at my baby. So this time, when I go back to my table, I'm going to focus on my G column to start. Or sorry, my G row to start, because my baby is G, and that's what I'm doing first. So when x is equal to 2, when the input's equal to 2, the output of the function is equal to 6. So G of 2 is equal to 6. All right, now I can just replace G of 2 with 6. So I get f of 2. Or sorry, G of 2 is not 2, G of 2 is 6. So I'm going to do f of 6. All right, so this might be a good time to return to the definition at the beginning of the problem. the output of one function is the input for another. Okay, this is starting to make a little bit more sense now, because as you can see, the output of G is becoming the input for F. So this is where the math steps up a level, because we're used to thinking input is one thing, output is another thing. Now we're seeing the output of one function can actually act as the input to another function. Okay, so now evaluate your mom. Okay, f of 6, right? Weird thing, my output is becoming my input into my new function. F of 6, need to go back up to my table and see where the input is equal to 6, and the function f is going to be equal to 248. So my final answer is 248. The output of one function has become the input into another. What I would like you to do now is go ahead and flip to worked examples 2.5. You are going to try 1 through 4. The answer key is linked on the home page. Check your work as you go. Come back and refer to this video as needed, and do Who is your mom that you always go from inside to outside. So evaluate your baby first and your mom second. All right, good luck. Talk to you soon.